Welcome to solverfy.
Hello everyone, today we're doing chapter 19, problem 28, and this problem asks us to give the IUPAC names for each of the following compounds here. So if we begin with the IUPAC name of A, well, let's just redraw this quickly so we can easily visualize this. So we have a carboxylic acid. We have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then on 1, 2, 3, 4. We have 1, 2, 3, 4. And then on this carbon 4, we have 2 methyls coming out. So the longest chain is going to be 5 carbons long. So remember, naming, you need to start with your parent chain being the longest straight chain. So it's going to be 5 carbons long, so we know it's going to be pentane. But it's not just a straight chain hydrocarbon, it's a carboxylic acid. So it's going to be pentanoic acid. So what else is attached to this pentanoic acid? Well, we have a methyl group counting from carbon 1 as this carboxylic carbon. We have 1, 2, 3, 4. So on carbon 4, we have a methyl. So we have 4-methyl pentanoic acid for A. Now what about for B? So B, we have a carboxylic acid, a carbon, and a bromine. So for B, we have 2 carbons. This is a straight chain. So we have ethanoic acid. And then on carbon 2, we have the bromine. So we have a 2-bromoethanoic acid. Now what about for C? So for C, if we count the longest straight chain, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 carbons. So that's octane, so octanoic acid. That's the parent chain. Remember, we count from the carboxylic acid carbon as being 1. So we have 1, 2, 3, 4. So in carbon 4, we have dimethyl. Carbon 5, we have dimethyl. So in total, we have 2 methyls on carbon 4, 2 methyls on carbon 5. We have tetramethyl in total, tetramethyl octanoic acid for C. Now, what about for D? So D, we now have a salt. So we know the salt name will come before anything else. So let's just write that out. So we have a lithium. And what's the parent chain? Well, we have now the carboxylate conjugate base, but we have 1, 2, 3, 4 carbons. So this is a butanoic acid. But remember, now because we have a lithium salt, we know that this is going to be the conjugate base, so it's no longer in its acidic form. It's in its conjugate base form. So we replace the oic acid suffix with the ate suffix. So it's a butanoate molecule here, and there's nothing attached to it, no substituent, so we have lithium butanoate. Now what about for B? So remember, your parent chain is your longest straight chain or your biggest cyclical moiety. So here we have a cyclopentane. So we can write that down, cyclopentane. And we have a carboxylic acid attached to it. So cyclopentane carboxylic acid. And then on carbon 1, being the carbon that the carboxylic acid is attached to, we have an ethyl substituent. So we can say 1-ethyl cyclopentane carboxylic acid. Now what about for F? So F, our parent chain is now the cyclohexane. And we have a carboxylic acid attached to it. And now this being carbon 1, we can count 2, 3, 4, 5, 6, or we count the other way, but we will know we count counterclockwise in this example because we need to keep the substituents the lowest ranking number possible. So on carbon 2, we have a methyl group, and on carbon 4, we have a methyl group. So we have a 2,4-dimethyl cyclohexane carboxylic acid for F. Now what about for B? So for G, sorry. So for G, we have a benzene ring. So for G, we have benzoic acid. So we have benzene ring with a carboxylic acid, and then ortho to it, we have a bromine. So we can say we have an O-bromobenzoic acid. Now what about for H? So we also have that benzoic acid. But now ortho, meta, para to it, we have 2 carbons being ethyl. So we have a p-ethyl benzoic acid, para-ethyl benzoic acid. Now what about for I? So I, we have 1, 2, 3, 4, 5, 6. We have 6 carbons, so we have a hexane. We have a hexanoic acid. And we have a substituent on carbon 2 being a 2-methyl. But now remember, this is not its acidic form anymore, it's the conjugate base form. So we need to add, or we need to remove the suffix oic acid and add the suffix ate. And we also have to add the salt, being sodium, in the very front. So we have a sodium 2-methylhexanoate. Now, last but not least, let's look at J. So J, we have the longest straight parent chain carbon number is 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's just count that again. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 here, but what if we count up here? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see? So this is the longest straight chain. So we have a decanoic acid, and then 1, 2, 3. On carbon 3, we have a methyl. Carbon 5, we have an isopropyl. Carbon 7, we have an ethyl. So in terms of alphabet, E is first from P, is first from M. So the ethyl will come first. So we have a 7-ethyl, and then 5 isopropyl, and then 3 methyl decanoic acid.